Welcome everyone. Today we are going to work with logarithmic equations, and we are going to see the relationship between the logarithmic equation and the exponential equation. Let's do some examples to identify the steps and the solution of the logarithmic equation. The first example, if we have logarithm by base 2 of x plus 3 equal 3. So we need to identify the base, that in this case is 2, the argument, that is x plus 3, and the solution of the logarithm is 3. So we can write the logarithm in form of exponential equation. So the base 2 to the third power is equal x plus 3. And solve. 2 to the third power is 8 equal x plus 3. And isolate the value of the variable x. So we are going to subtract 3 to both sides. So x equal 5. Let's do a second example. If we have 2 times logarithm base 3 of x equal logarithm base 3 of 25. There are one property of logarithms that says that if there are one number multiplied by logarithm, this is the exponent of the argument. So we can write logarithm base 3 of x to the second power equal logarithm base 3 of 25. So if we have the same base, we can equal the arguments. So x to the second power equal 25. So the solution, we are going to take the square root, and the solution is positive or negative. So x is equal, the square root of 25 is 5. So it's plus or negative 5. So one solution is x is 5, or the other solution is x equal negative 5. In this case, if we have negative 5 and substitute in the argument, but we are going to elevate to the second power, is 25 positive. So it's possible the answer. Let's do another example. If we have logarithm base 3 of x plus 3 plus logarithm base 3 of x plus 5 equal 1. One property of the logarithms is if we add logarithms with the same base, we can write the logarithm base 3 of the product of the two arguments, x plus 3 times x plus 5 equal 1. Now we need to write the logarithm in exponent form. So the base 3 to the exponent 1 equal the argument, that is x plus 3 times x plus 5. So we need to do the distributive property. 3 to the 1 power is 3 equal x times x to the second power, plus x times 5, 5x, plus 3 times x is 3x, plus 3 times 5 is 15. So we are going to add the like terms. So x to the second power plus 8x plus 15. And now we are going to equal to 0 the equation. So 0 equal x to the second power plus 8 times x plus 15 minus 3, and add the like terms. 0 equal x to the second power plus 8 times x plus 12. And now we are going to factor the polynomial. In this case, we have x plus and x plus. And we are going to find two numbers that multiply 12, but the addition is 8. In this case, 6 and 2. So the possible solution is x plus 6 equals 0 or x plus 2 equals 0. In the first case, x equal negative 6, and the second case, x equal negative 2. In this case, if we substitute negative 6 in the principal equation, the argument is negative. So the logarithm, the argument can't be negative. So negative 6 is not the solution. But if we substitute x by negative 2, we have negative 2 plus 3 is 1 positive, and negative 2 plus 5 is 3 positive. So the solution in this case is x equal negative 2. Let's do another example. Here we have logarithm base 2 of x plus 2 plus logarithm base 2 of x plus 4 equal logarithm base 2 of 2. The property, if at two logarithms with the same base, we can multiply the arguments. So we can write logarithm base 2 of x plus 2 times x plus 4 equal logarithm base 2 of 2. If the base of the logarithm is the same, the argument is the same. So we can write x plus 2 by x plus 4 equal to. First, we need to do the distributive property. X times x is x to the second power. X times 4 is 4x. 2 times x is 2x. And 2 times 4 is 8. Equal to. Add the like terms, x to the second power plus 6 times x plus 8 equal to. Now we need to equal the equation to 0. So x to the second power plus 6 times x plus 8 minus 2 equal 0. Now add the like terms. So x to the second power plus 6 times x plus 6 equals 0. So to solve the quadratic equation, we can solve for completing the square or use the quadratic formula. I'm going to use the completing the square. In this case, we are going to group x to the second power plus 6 times x. And we are going to form a quadratic trinomial. So this is x to the second power plus 6 times x plus 6 divided by 2, 3 to the second power, and we need to subtract the same expression, 3 to the second power plus 6 equals 0. So the trinomial is a perfect square trinomial. So the factorization is the square root of x to the second power, the square root of 3, the addition of that squares to the second power, minus 9 plus 6 equal 0. So x plus 3 to the second power minus 3 equals 0. And we need to isolate the expression with the square. In this case, x plus 3 to the second power equal 3. Now we are going to take the square root, and the solution is positive or negative. In this case, x plus 3 equal positive or negative square root of 3. So x is equal to negative 3 positive negative square root of 3. If we have the negative solution, the argument of the first logarithm is negative, so it is not possible that solution. The solution is x equal negative 3 plus square root of 3. That is the solution of the equation. But what happens if we have 3 to the x power equal 8? This is an exponential equation. So we need to rewrite in logarithmic equation. In this case, the base is 3. So we can write logarithm base 3 of 8 is equal to x. So one property of the logarithms, we said that if we have this condition, we can rewrite the logarithm like logarithm base 10 of 8 over logarithm base 10 of 3. And that is the solution. If you need to find the numerical solution, you have to use the calculator and find the possible solution. I hope you learn how to use the properties of logarithms, the relationship between logarithm and exponential for the solution of logarithm equation. See you in another opportunity.